Hello class, our topic is about solving rational inequality. Compared to solving rational equations, this topic is quite harder and tricky. Here are the steps. Suppose we're going to solve the rational inequality 4x minus 2 over x plus 3 is greater than 2. The first thing that we do is that we have to make the right side of the equation 0, and that is by transposing 2. Remember that transposing a term or a number changes its sign. Therefore, we have 4x minus 2 over x plus 3. From positive 2, that becomes negative 2 is greater than 0. So, again, that is according to the first step. Next thing is to make the left side a monomial or a single term only. Therefore, we perform the operation between the two terms. So that is subtraction. I have used the shortcut method, which is the butterfly method. So 1 times the quantity of 4x minus 2 minus 2 times the quantity of x plus 3. You have learned this technique in your lower years. And then copy greater than 0. It is called butterfly method because of the technique that the numerator of the second fraction is multiplied to the numerator of the first fraction. And then the denominator of the first fraction multiplied to the numerator of the first fraction. So simplifying, we have 4x minus 2 minus 2x minus 6. We just simply distributed 2 to the quantity of x plus 3. Therefore, we have 4x minus 2x, we have 2x, and then negative 2 minus 6, we have 8. Negative 8 rather. Over x plus 3 is greater than 0. For the third step, let us equate the numerator and denominator to 0. So we have 2x minus 8 equals 0. We transpose 8, so we have 2x equals 8. And then dividing both sides by 2, we have x is equal to 4. And that is for the numerator. For the denominator, we have x plus 3 equals 0. We transpose 3, that becomes negative 3, just like what we did in the numerator. Therefore, we have x equals negative 3. So in these steps, the next thing that we do is that we have to make a table of sign. But before that, to be able for us to identify the correct regions, let us first do it in the number line. And now we plot 4 and negative 3 in the number line using open circles. It means that 4 and negative 3 are not part of the solution. We used open circle for greater than or less than inequalities, while closed circle for greater than or equal, or less than or equal. For the first region, we have numbers that are less than negative 3. That is, open close parenthesis, negative infinity and 3. For the right side, we have 4 to positive infinity. That means that the numbers that are greater than 4. For the middle, we have numbers that are in between negative 3 and 4. Below is the rule form. We have x less than negative 3. For the right side, we have x greater than 4. And for the middle, we have numbers that are less than 4 but greater than negative 3. For the table of values, we put the regions in the column, and we write the numerator, the denominator, and the term on our left side of the equation. For the regions, we have to make representations. Say, numbers that are less than negative 3. Say we have negative 4. So we write this, say 4, negative 4 rather. For the middle term, it says that the numbers that are in between negative 3 and 4, say 0. And then for the right side, numbers that are greater than 4, say 5. So it's up to you to choose the numbers that you want to represent the regions that we are using. So we substitute negative 4 to 2x minus 8. 2 times negative 4 is negative 8. Negative 8 minus 8 is negative 16. That's why we put negative in that box. Say 0. So again, we substitute 0 to 2x minus 8. Again, it resulted to a negative result or negative answer. That's why again we put negative in that box. For the third row, or third column rather, we substituted 5 and then it resulted to positive 2. Therefore, we put positive. Next, for x plus 3, again substituting negative 4. Negative 4 plus 3 is negative 1. Again, we put negative. And then 0. 0 plus 3, we have positive 3. Therefore, we put positive. And then for the third column, substituting 5. 5 plus 3 is positive 8. Therefore, we have positive. And now for the last row, the numerator 2x minus 8 is negative. The denominator x plus 3 is negative. Negative divided by negative is positive. Remember that in division, dividing similar signs results to positive, and dividing different signs results to negative. We have negative divided by positive. The answer is negative. And then, for the third column, 2x minus 8 there is positive, and then x plus 3 there is also positive. Positive divided by positive, that is positive. And now, we're going to choose from those three regions which is the correct one. Again, going back to our inequality, 2x minus 8 over x plus 3 is greater than 0. The numbers that are greater than 0 are the positive numbers. Therefore, we are going from our regions, we are going to choose the ones that resulted to positive. That's why we have the first region and we have third region as our answer. Therefore, for the final answer, we have x is equal to the union of negative 3 to negative infinity and 4 to positive infinity. Remember that the parenthesis before a number in this instance means that the numbers before or after it is not included in the solution. Or, for the rule form, we have x such that x is less than negative 3 or x is greater than 4. And that is the solution. Now, for the next example, we have x minus 6 over x squared minus 4 is less than 0. In this example, first we have to factor out the denominator. Therefore, we have x minus 6 equals 0, and that resulted to x is equal to 6. And then positive 2, x plus 2, that becomes x equals negative 2. And x minus 2, that becomes x is equal to 2. Again, we plot it in the number line using open circles. We have negative 2, we have 2 and 6. In this instance, we have 4 regions to solve. First, numbers less than negative 2. We have numbers in between negative 2 and 2. We have numbers between 2 and 6. And we have numbers greater than 6. We have 4 regions, just like what I have said. So we have to name these regions. First, negative infinity and negative 2. Next, in between negative 2 and 2. In between 2 and 6 rather. Next, 6 to positive infinity. Or in rule form, we have x less than negative 2. X greater than negative 2 but less than 2. X greater than 2 but less than 6. And x greater than 6. Again, putting the 4 regions in the columns. And then, putting the numerator and the denominators in the row. We have x minus 6. We have x plus 2. We have x minus 2. And then the complete term in the left side of the inequality. Again, making representations. Numbers that are less than negative 2. Say we have negative 3. And the numbers that are in between negative 2 and 2. Say 0. Next, numbers that are in between 2 and 6. Say 4. Numbers that are greater than 6. Say 7. Again, it's up to you to choose the numbers that you want to represent the regions. But make it sure that you're using the correct numbers, okay? Again, we substitute negative 3 to x minus 6. So, negative 3 minus 6 is negative 9. Resulted to negative. And now, following the same pattern, and for the fourth row, we have x minus 6 is negative over x plus 2 is negative times x minus 2 is negative. So negative over negative times negative in the denominator results to positive. Negative divided by positive is negative. And then we have negative over positive times negative. We have negative over negative, that is positive. And then negative over positive times positive, that is negative. And then we have x minus 6 is negative, x plus 2 is positive, x minus 2 is positive. And then positive over positive, and that is positive. Again, going back to the inequality, we have used less than. The numbers that are less than 0 are the negative numbers. Therefore, we are going to choose the region that resulted to negative. So we have the answer. X equals the interval from negative 2 to negative infinity, union 2 and 6. And for the rule form, by the way, our first answer is in the interval notation. For the rule form, we have x such that x is less than negative 2 or x is greater than 2 but less than 6. That is all. Thanks for watching.